Hi, welcome to the 8th functions tutorial titled Basic Cumulative Functions. In today's tutorial, we are going to be going through examples whereby many different functions are integrated into one question. All of the work that we'll be doing in today's tutorial is worked examples. Thereafter, we will move on to the next tutorial, which is titled Advanced Cumulative Functions. In terms of what you need to know to progress with today's tutorial, you need to be familiar with your grade 10 work. You also need to have worked through the first 7 functions tutorials. The example I'm going to use to illustrate how we're going to progress on with the rest of this tutorial is as follows. Draw in the same set of axes the following graphs. First one, f of x is equal to 3 to the power x. The next one, g of x is equal to 1 over 3 to the power x. H of x is equal to negative 3 to the power x. And the last one, j of x is the inverse of f of x. Basically, we are looking for j of x, which is f minus 1x, which means that j of x is the inverse of f of x. And then I also asked you to give me the equation of j of x. We are not going to do this using the table method or any other long drawn out methods. We are simply going to sketch the graph roughly. Obviously you need to draw your axis a bit neater than I do. The first graph we're going to draw in is the graph f of x is equal to 3 to the power x. F of x is equal to 3 to the power x will look something like that, and that's simply f of x. To draw the graph g of x is equal to 1 over 3 to the power x. Isn't that the same as 3 to the power negative x? Isn't that the same as, well, very similar to that, except there's a negative in front of the x, which means that we've flipped it around the y-axis. That means that our graph looks something like that. And that's the graph g of x. Straightforward. Passes through the point x is equal to 0, y is equal to 1. Even f of x passes through that point. The next graph that we're looking for is the graph h of x is equal to negative 3x. Now negative 3x, isn't that the same as saying negative hx is equal to 3x? Which means that we are looking for the negative of f of x, which means we are flipping it around the x-axis. So we are taking f of x and we are flipping it around the x-axis, and that gives us h of x. So those 3 graphs were very easy to draw. We're now going to draw the graph j of x, which is the inverse of f of x. Now the inverse of f of x means that we are going to flip the graph around the line x is equal to y, which means that j of x is going to be given by this line over here, passing through x is equal to 1, y is equal to 0, and that's the graph j of x. That second blue graph is the graph j of x. All it is the graph of f flipped around the line y is equal to x. How do we get the equation of j of x? I'm going to do that in black. How do we get the equation of j of x? Well, j of x is exactly the inverse of that. Now that f of x is the same as saying y is equal to 3 to the power x. That means to get j of x, all we're going to do is we are going to swap our x and our y values around. That's still 3. But we always want our functions in the form y is equal to. So we are going to use logarithms. Log, this 3 moves to the bottom. Log base 3x is equal to y. That means that j of x is equal to log base 3x. And that's the equation of that line, of that graph rather. Have a go at the following exercise, and when you return we'll go through it together. The first one I gave you to do read, sketch on the same set of x's f of x is equal to 3x minus 5, g of x is equal to 9x minus 5, and h of x is equal, let's do this over here, h of x is equal to minus 3x plus 5. I'm going to start by drawing my set of x's. Now notice that I'm no longer doing long calculations at all to get to my graphs. I don't need to unless they say draw it accurately. But in this case here, it is very easy to sketch a rough set of x's and to just sketch the graph on there. Starting off with f of x, firstly, when x is equal to 0, our y-intercept is going to be negative 5. When y is equal to 0, it means that 3x minus 5 is equal to 0, which means that 3x is equal to positive 5, which means that x is equal to positive 5 over 3, which is going to be over here. And that's 5 over 3. If you are not drawing your graphs exactly accurate to scale, label all of those points that you are drawing in. You'll see it becomes very helpful when we start to do transformations. Always label your graphs. The next graph I asked you to do was g of x is equal to 9x minus 5. Two ways of doing this. Firstly, we could say that our gradient has tripled, which means that it's going to be a much steeper slope, although that's going to be a little bit complicated to do. What I'm going to do is I'm going to sketch g of x as if I was sketching any ordinary graph. When x is equal to 0, y is equal to negative 5. And when y is equal to 0, it means that 9x minus 5 is equal to 0, which means that 9x is equal to positive 5, which means that x is equal to positive 5 over 9. Which means that this straight line graph is going to come in over here. And that's the graph g of x passing through 5 over 9. By the way, 5 over 9 is a third of 5 over 3. So our y-intercept has stayed the same, except our graph is much more positively sloped. The last one I gave you to do, that h of x is equal to negative 3x plus 5. Now before you try and sketch this one, yes, you can sketch it the way I've been drawing these two, but look at this very carefully. Isn't that the negative of that? Negative times that will make it negative 3x plus 5. Negative 3x plus 5. Which means that h of x is us taking the graph f of x and flipping it around the x-axis, which means essentially that it's going to still cut through that point, except it's now going to cut the y-axis at positive 5. Remember, it's of h of x, of f of x. It's got nothing to do with the g of x graph, which means that this graph is going to look like that. And that is the graph h of x. It's just the f of x graph that's been flipped around the x-axis. The next one I gave you to do read f of x is equal to negative 3 over x plus 6 plus 5. G of x is equal to negative 3 over x plus 6 plus 8. And the third one I wanted you to do was h of x is equal to the inverse of f of x. We are not going to use table method or anything like that to draw these graphs any longer. We are now going to do it simply by inspection. This is our x-axis, our y-axis, 0. Firstly, what type of graph is f of x? F of x is a hyperbola. It's easy to see because x is in our denominator. So it's a fraction graph, it's our hyperbola, which normally has asymptotes y cannot equal 0, which is that x-axis over there, and x cannot equal 0, which is the y-axis. However, and the standard graph should look like that. Should be something like that. The first thing we're going to notice is that we've got a negative 3 in the numerator, which means that it's the negative graph, which means that we are now not looking for that graph, but it's been flipped around the y-axis and flipped around the x-axis, either or. So we are looking for the negative hyperbola graph. That's the first thing we're going to look at. Secondly, our denominator says x plus 6, which means that our graph is moved 6 units to the left. That means that our new asymptote is now not at x is equal to 0, but at x is equal to negative 6. This is the asymptote, x is equal to negative 6. This graph here cannot ever equal negative 6, which means that our graph is now asymptote around x is equal to negative 6, which means that it looks something like that. But we've also moved it plus 5 units. That means that our new y asymptote is at x is equal, y is equal to 5. That means that our graph is now shifted 5 units up. And this here is the graph of f of x. That is the standard graph, or this rather is the graph f of x. It's been moved firstly it's been negative flipped, it's been moved 6 units to the left, and it's been moved 5 units up, and that gives us the graph f of x. I'm just going to extend my y-axis a little bit. We are now going to look at g of x. Now have a look at g of x. Is g of x not the exact same thing as f of x? Except 5 plus 3 is 8, so it's been moved 3 units up from f of x. That means that g of x has an asymptote not at 5 but at 8. We've moved it 3 units up. It still has the same x asymptote, which means that the graph g of x is going to look like that, still the same asymptote, and that's the graph g of x. All it is the f of x graph shifted 3 units upward. The last one we are going to look at is the graph h of x, which is the inverse of f of x. Now this is going to be a fun graph to draw. Remember that the inverse is inverted around the line y is equal to x. Now think about this. If I'm taking the black graph, which is f of x, and I'm inverting it around that line, doesn't it mean that my asymptotes change as well? Notice with the hyperbola, we're not really sketching our graph as much as we are focusing on our asymptotes, because our graph falls around our asymptotes. If I invert it, I'm going to have one asymptote of x cannot equal 5. That asymptote has been inverted from the y-axis onto the x-axis. And the other asymptote is going to be y cannot equal negative 6. That means that we've taken the asymptote on the x-axis and we've converted it to an asymptote on the y-axis. So that's the negative 6 and that's the 5 asymptote. Now we need to invert our graph around that. Basically all that means is that our graph is going to intercept there, it's going to follow this pattern and that pattern over there, so it's going to look like that. The next one I gave you to do said f of x is equal to negative 2 to the power x, g of x is equal to f of x plus 3, h of x is equal to f of x plus 2, and the last one, j of x is equal to the inverse function of f of x, plus I wanted you to find the equation of j of x. We're going to start this one out by drawing the standard f of x graph. Going to start with my x's as usual. Firstly, f of x is equal to negative 2x. Now the standard graph f of x, or rather the standard graph f of x is equal to negative 2 to the power x is an exponential graph. So it should be over here, following that pattern over there and cutting through 1. But we've now made y negative because it's now negative 2 to the power x By the way, it's negative 2 to the power x, almost as if it's in brackets. So what's going to happen here is, because we've got a negative in front of the y, we've basically flipped it around the x-axis, which means that our graph is going to be that graph flipped around the x-axis, which is going to be over there. And that's the graph f of x passing through the point 1, never with an asymptote of y is equal to 0, or rather y cannot ever equal 0. The next graph we're looking at is g of x is equal to f of x plus 3. All that's happened with g of x is we've taken our f of x graph, which is over here, and we've shifted it 3 units upward. 1, 2, 3 units, which means that it will cut through y is equal to 2, and our asymptote, which was at y is equal to 0, will now occur at y is equal to 3. And that's the asymptote, y is equal to 3. We've got to draw in our asymptote. Here we didn't have to, because our asymptote was on the x-axis. That means that the graph g of x is going to be our standard f of x graph, and it's going to look like that. It's passing through the point y is equal to 2. By the way, this is a negative one. Y is equal to 2. I can calculate this point if I want to, that x value. That's just going to be the x value when negative 2 to the power x is equal to 0. No, sorry, negative 2 to the power x plus 3 is equal to 0. That means that negative 2 to the power x is equal to negative 3. I can use logs for this. That means that x is equal to, well, first I can divide through by the negative. That means that x is going to equal to log base 2 to the 3, which I don't need to find out. We are now going to look at the graph h of x. Now h of x is f of x plus 2, which means that it's still our f of x graph, except it's been shifted 2 units to the left, which means essentially that h of x's equation is equal to negative 2 to the power x plus 2. All we are doing is we are taking this graph and we are shifting it 2 units to the left, which means that our graph will now look like that. And that's the graph h of x. I can calculate that point there, the point where h of x intercepts the y-axis. Remember, it's still following the same asymptote of y cannot equal 0. Now the reason y cannot equal 0 is because negative 2 to the power x plus 2 still can't ever equal 0. What's that point over there? That's the point y is equal to negative 2 to the power 0 plus 2, which is equal to negative 2 to the power 2, which is equal to negative 4. 2 to the 2 is 4, negative times 4 is 4. So that's the point negative 4, if I need to calculate that. The next graph we're going to be looking at is j of x. Now j of x is the inverse of f of x. The inverse of f of x means that we are flipping it around the line y is equal to x. So we are taking this graph and we are flipping it around that line, which means that our graph j of x, given in as the blue graph, the new blue graph, is going to be given by that graph over there, and that's j of x. That's going to pass the point -1. Pass through the point -1 rather. We are now looking for the equation of j of x. Remember, the equation of y of x was basically y is equal to -2 to the power x, or minus 2 to the power x. To get the inverse means that we are going to swap these two around. That means that x is equal to -2 to the power y, which means that y is equal to negative log base 2 x. All we've done is we've swapped it around. We've inverted it. The next one we're going to look at, number 4, says on the same set of x's, sketch f of x is equal to -6 plus 3x squared plus 2x, and then g of x is equal to f of x minus 2. We're going to start off with the f of x graph. Unfortunately, this one we can't sketch just by inspection as we were doing with hyperbola and exponential and straight line. We are going to have to do some calculations to the f of x graph in order to sketch it. Firstly, I'm going to change the form of it. I'm going to get it into the form ax squared, which will be 3x squared, plus bx, which is plus 2x, minus 6. Ax squared plus bx plus c. Now to sketch this graph, we're going to start off by looking at our a value. In this case, our a value is positive 3, which means that our graph has a smiley face. Next thing we're going to look for is axis of symmetry. Axis of symmetry happens when x is equal to minus b over 2a, which means that x is equal to minus b, which is minus 2 over 2a, which is 2 times 3, which is 6. So our axis of symmetry happens at x is equal to -2 over 6, which is the same as -1 over 3. Our turning point happens at f of -1 over 3, which is equal to 3 times -1 over 3 squared plus 2 times -1 over 3 minus 6, which is going to give us -1 over 3 squared is going to give me positive 1 over 9. 1 over 9 times 3. 1 over 9 times 3 is the same as 3 over 9, which is the same as 1 over 3. Plus 2 times -1 over 3 is going to give me -2 over 3 minus 6, which is the same as minus 18 over 3. 1 minus 2 minus 18 is going to give me minus 19 over 3. That means that our turning point is given by -1 over 3 and -19 over 3. That's that. Now we need to look at our x-intercepts. Our x-intercepts, remember, are going to be given as the x values when y is equal to 0. That means that to get our x-intercepts, we make f of x equal to 0. 3x squared plus 2x minus 6 is equal to 0. 3 times 6 is equal to 18. Are there any factors of 18 that will give us 2? No, there aren't. Hence we are going to have to factorize this, or rather we are going to have to find the x values by using the quadratic formula. X is equal to minus b plus minus square root of b squared minus 4ac all over 2a. 2 squared is equal to 4. Minus 4 times minus 6 times 3 is going to give me positive. 4 times 3 is 12, times 6 is 72. So it's 4 plus 72, which is equal to 76. By the way, all of this you can do on your calculator. So it's minus 2 plus or minus square root of 76 over 6. Which means that x is either equal to negative 2 plus root 76. 4 goes into 76 19 times. So that will be plus 2 root 19 over 6, which we can simplify into being negative 1 plus root 19 over 3. Or x is equal to negative 1 minus root 19 over 3. The problem with this is, where do we sketch this on our axis? What I'm going to do is I'm going to simplify this into its, take it out of its third form, put it into decimal form, which is going to give me an answer of 1.12. My one x-intercept is x is equal to 1.12. My other x-intercept is going to equal negative 1 minus root 19 over 3, which is going to be negative 1.77. My y-intercept happens when x is equal to 0, which will be at negative 6. I can now sketch this graph. We're going to need a set of axes. X-axis, y-axis. Firstly, our turning point happens at x is equal to negative 1 over 3, which is somewhere over here, and negative 19 over 3, which is way down here. Let's just extend this axis a little bit. That's our turning point. That's our y-intercept at negative 6. Notice that negative 19 over 3 and negative 6 are very close together. Our two x-intercepts are one at x is equal to 1.12 and the other at x is equal to negative 1.77, which means that our graph is going to look like this, and this is the graph f of x. Now we are going to look at sketching the graph g of x. Although we don't need to do any calculations at all to sketch this graph, g of x is equal to f of x minus 2, which means that we are taking our f of x graph and we are shifting it 2 units to the right, which means that it's going to be the standard graph like that, and it's going to look like that. And that is the graph g of x. All that's happened is it's moved 2 units to the right because it was f of x minus 2. Which means that our new turning point is going to have an x value of negative 1 over 3 plus 2 and a y value still of negative 19.3. Our two x-intercepts are going to be that plus 2 and that plus 2, which makes both of them positive. And our y-intercept is going to be a lot higher. If I wanted to calculate my y-intercept, I'm going to have to substitute x plus 2 into each place where I've got an x, which will become a little bit tedious. I don't want you to do that. The next one I gave you to do says, on the same set of axes, sketch the graphs of f of x is equal to 2 sine x, g of x is equal to f of x minus 30 degrees, and lastly h of x is equal to a half f of x. Quite an easy three to draw. We're going to start off with our axis. Oh, I forgot to put in my restrictions here. I said that x has a range, rather, not restrictions, of negative 180 degrees all the way up to positive 180 degrees. That's my y-axis, x-axis, negative 180 degrees, negative 90 degrees, 0, 90 degrees, and positive 180 degrees. The first graph we're sketching is that of f of x, which is equal to 2 sine x. Sine of 0 is equal to 0 times 2 is 0. Sine of 90 is equal to 1 times 2 is going to equal 2. Sine of 180 is 0 times 2 is 0. Sine of negative 90 is negative 1 times 2 is negative 2. Sine of negative 180 is 0 times 2 is 0. Sorry. That means that my graph f of x is going to look like this. To draw the graph g of x is equal to f of x minus 30 degrees, which means that we are taking our f of x graph and we are moving it 30 degrees to the right. So it's not going to pass through at 0 any longer, it's going to pass through at 30. It's not going to peak at 90, it's going to peak at 120 degrees, and it's not going to drop down at 180 but rather at 210 degrees, which is beyond our range. It's not going to be peaking again at negative 90, it's going to be peaking at negative 60, and not at negative 180 but rather at negative 150, which means essentially that our graph is going to be looking like this. All we've done is we've taken our standard f of x graph and we've shifted it 2 units, we've shifted it 30 degrees to the right. Please stop at negative 180 and at positive 180. The next graph we're looking at is h of x is equal to a half of f of x. Well, let's think about this. When f of x is equal to 0, 0 times a half is 0. When f of x is equal to 2, a half times 2 is 1. Notice all that's happening is that we're taking our graph f of x and we're just making the amplitudes and the troughs smaller. Oh, and that's the graph h of x. Please don't make the mistake I just made and forget to label your graphs. The sixth one I gave you to do said, on the same set of axes, sketch the graphs of f of x is equal to sine x and g of x is equal to cos x. and I told you to sketch it for the range x is an element of 0 degrees all the way up to 360 degrees. I'm going to start off with f of x, and I'm not going to draw too big of a graph. It's 90 degrees, 180 degrees, 270 degrees, and 360 degrees, and obviously that's 0. Let's make that the point 1 and negative 1. To draw sine of x, the standard sine of x graph is going to look like this, and that's the graph sine of x. The next graph we're drawing is that of g of x. I forgot to label it again. The next graph we're drawing is that of g of x, which is equal to cos x. Cos of 0 is 1, cos of 90 is 0, cos of 180 is negative 1, cos of 270 is equal to 0, and cos of 360 is equal to positive 1. Notice when we draw these two graphs, just by the way, they're very much alike when we look at it as being only from 0 to 360 degrees. The cos graph and the sine graph are basically exactly the same, except the only difference is that the cos graph is 90 degrees either side of the sine graph. You can either look at it as being 90 degrees ahead of the sine graph or 90 degrees behind the sine graph. I then said, on a new set of axes, sketch the graph h of x, and h of x is given by f of x divided by g of x. I then also wanted you to draw the graph of j of x, which is given as h of 2x. Let's start by looking what this h of x graph is going to be. F of x divided by g of x, isn't that the exact same thing as saying f of x over g of x, which is the same as saying sine x over cos x, which is the same as 10 of x. That means that h of x is the graph 10x. I'm going to draw that also from 0 degrees to 360 degrees. 0, 90, 180, 270, and 360 degrees. Now the 10 of x graph has an asymptote at 90. It's also got an asymptote at 270, and it follows this pattern, never touching the asymptotes. Alright, that's the graph h of x. Always label it. The next graph we're looking for is j of x is equal to h of 2x, which means that basically j of x is equal to 10 of 2x. 10 of 2x means that our asymptote is no longer going to be at 90 but rather at 45 degrees. Our 270 degree asymptote is no longer going to be at 270 but rather at a half of 270, which is 135. Our next asymptote is going to be the asymptote that should be 450 degrees. Half of 450 degrees is 225 degrees, which is going to go over here. Notice that this graph is going to start looking very much, or basically we've compressed the graph, we've doubled the graph. The next one is going to go up to 270, and that asymptote over there is going to be at between 270 and 360 degrees, which is going to be the asymptote 315 degrees. And then finally our graph is going to look like that, and that ends at 360. That means that we've basically doubled the amount of 10 graphs we have. Label it J of x. The last one I gave you to do read f of x is equal to x squared plus 14x plus 10 shares a turning point with g of x, which is equal to 3x minus p squared plus q. I then asked you to calculate the values of p and q. Remember that they share the same turning point, and then to sketch both of the graphs. Now in order to do that, remember that this is in the form a x minus p squared plus q, and pq is the coordinates of our turning point, and that is the same coordinates as the turning point of this graph. How will I get the turning point of this graph? There's two methods I can use. The one is by completing the square, which I'm going to use. F of x is equal to x squared plus 14x plus 14 over 2 squared minus 14 over 2 squared plus 10. I've just added that in. The reason I've done that is so that I can turn this into x plus 14 over 2 is 7, so it's x plus 7 squared minus 7 plus 10 is going to give me plus 3. That means my turning point of f is going to be given by, remember it's x minus p, so my turning point is given by minus 7 and a y value of plus q or 3. That means that PQ have the coordinates negative 7 and 3. Both graphs have a turning point of negative 7, 3. That gives me my turning point of both graphs, which is already more than halfway there. I've now got to calculate my x-intercepts of the graphs separately. Of this graph here, to calculate my x-intercepts is when x squared plus 14x plus 10 is equal to 0. Can this be factorized? No, it can't. But remember that if I did use completing the square, I would have had it in the form x plus 7 all squared plus 3 is equal to 0, or rather is equal to negative 3. Which means that this graph here has got no x-intercept, because square root of negative 3, to get rid of the squared, is undefined, which means that this graph has got no x-intercept. So this graph, the graph of f, has got a distinct turning